What if I told you that we are on the brink of becoming interstellar travelers? That's right, you and I, venturing into the cosmos. Welcome to Cosmic Paradise, where today we're embarking on a journey through the stars. Fasten your seatbelts because we're about to explore how close, and yet how far, we are from conquering the vast distances of space. Let's start with a bang. Did you know that the first human-made object to reach space was the German V-2 rocket in 1942? And since then, we've been reaching for the stars, quite literally. But space is big, really big. So how far have we actually gone? Our cosmic backyard, the solar system, is our first stop. We've sent probes to every corner from the scorching surface of Venus to the icy realms of Pluto. And humans, we've been to the moon. That's 384,400 kilometers away, a small step in the universe, but a giant leap for humankind. Here's a thought to stretch your imagination. There are more stars in the universe than grains of sand on all the Earth's beaches and deserts combined. That's billions upon billions of stars, each potentially a sun to its own solar system. And if you think Earth has a lot of water, think again. There's a colossal reservoir of water floating in space, containing 140 trillion times the amount of water in Earth's oceans. It's the largest water vapor cloud we've ever discovered, floating around a black hole, no less. Our solar system is on a cosmic carousel, taking about 230 million years to complete just one orbit around the Milky Way. So, the last time Earth was in this position, dinosaurs were just starting to roam the planet. Now back to our journey. Mars, our red neighbor, is next on the list. It's about 225 million kilometers away when it's closest to Earth. We've got rovers rolling on its surface looking for signs of past life. And guess what? We're planning to send humans there too, with missions like NASA's Artemis program aiming for boots on Martian soil by the 2030s. But let's dream bigger. The nearest star system, Alpha Centauri, is a staggering 4.37 light-years away. That's about 41 trillion kilometers. A message sent at the speed of light would take 4 years to reach its destination. Imagine waiting 8 years for a reply to a simple hello. With current technology, it would take us tens of thousands of years to get there. Seems far? Enter the new age of space travel. Companies are building rockets that could take us to Mars in months, not years. And scientists are working on propulsion systems that could reach a fraction of the speed of light. The future is closer than you think. But it's not just about speed. Space travel is about endurance, innovation, and the human spirit. It's about the curiosity that drives us to explore the unknown and the resilience to overcome challenges. So, what's holding us back? It's a mix of technology, resources, and, well, physics. As we dream of setting foot on Mars, we must also face the stark realities of the red planet. Mars is not Earth's twin. It's a world of extremes, and living there will be our greatest challenge yet. First, the terrain. Mars is a desolate place, with an atmosphere almost 100 times less dense than Earth's. Temperatures can plummet to a chilling average of -81 degrees Fahrenheit, and the gravity is only about 38% of Earth's. To call Mars home, we'll need to overcome these hurdles. Our habitats must be robust, capable of shielding us from extreme temperatures and dust storms. They'll need to simulate Earth-like conditions, providing warmth, air, and gravity. Water is scarce, and the thin atmosphere lacks oxygen. We'll need to master the art of extracting water from the soil and producing oxygen from carbon dioxide, ensuring a sustainable supply of life's essentials. Radiation is another invisible enemy. Without Earth's protective magnetic field, solar and cosmic radiation bombard the surface. Our technology must shield us from this hazard, preserving our health in this alien world. Food will be another puzzle to solve. We can't rely on supplies from Earth forever. We'll need to grow our own food on Mars, creating greenhouses that defy the barren landscape outside. Overcoming these obstacles will not only allow us to survive on Mars, but will also drive innovation and growth and prepare us for our next step into the cosmos, interstellar travel. If you think traveling to Mars is hard, well, think again. Interstellar travel, it's a journey that stretches not just across space, but also the limits of our current technology and imagination. The vastness of space is our first hurdle. The immense distances require enormous amounts of energy, far beyond what our current spacecraft can carry. We'll need new propulsion technologies or energy sources to power these epic journeys. Then there's the human aspect. Our bodies aren't made for long-term space travel. Weightlessness weakens muscles and bones, while cosmic radiation increases the risk of cancer. We must develop countermeasures to protect the health of astronauts on these long voyages. And we can't forget the psychological toll. The isolation and confinement of space travel can affect mental health. We're social beings, and the loneliness of the cosmos is a real challenge for interstellar voyagers. The interstellar medium itself poses risks. Dust and gas between stars can damage spacecraft over time. We'll need to design ships that can withstand these hazards for centuries. Solving these problems will push the boundaries of science and engineering. Each breakthrough brings us one step closer to the stars and to understand our place in the universe. As our spacecraft hurtles toward distant exoplanets, we're not just carrying technology and dreams, we're also carrying our values, our humanity. The ethics of interstellar colonization weigh heavily upon us. First, who gets a seat on this cosmic ark? As we select our crew, we face questions of fairness, representation, and diversity. Should it be based on expertise, nationality, or something else entirely? And what about generations born in transit? Their lives will unfold entirely within these metal walls. And when we arrive at our new home, what rights do we have over the native ecosystems? Are we stewards or conquerors? Our actions will shape the destiny of these alien worlds. Do we tread lightly, preserving their uniqueness, or do we terraform, altering them to suit our needs? Then there's the question of legacy. What stories do we carry from Earth? What knowledge, art, and culture? How do we ensure that our past isn't lost in the vastness of space? Perhaps we become cosmic bards, singing our history across the light years. And what about those left behind? The families who waved goodbye, knowing they'd never see their loved ones again. How do we balance the pursuit of the stars with the bonds of family and community? Is the promise of a new world worth the sacrifice? On Mars or beyond, we'll build societies. But what kind? Will we repeat the mistakes of our past or forge new paths? How do we prevent inequality, exploitation, and power imbalances? Can we create a utopia, or will our flaws follow us across the cosmos? These are questions we must answer when the call for interstellar travel arises. Are we going to make right call? I want to hear your thoughts in the comments below. We can't talk about interstellar travel without talking about communication. As we set our sights on distant stars, we must also consider how we'll communicate across the vastness of space. Interstellar communication is fraught with challenges that stretch the limits of our current understanding. According to Einstein's theory of special relativity, time itself behaves differently at high speeds. This phenomenon, known as time dilation, means that time passes slower for those traveling close to the speed of light compared to those left behind. For interstellar travelers, this could result in years-long communication delays, complicating real-time conversations and coordination. To overcome these obstacles, we might need a network of probes or relays, akin to cellular towers in space, to boost and direct our messages. This interstellar communication network would help us maintain contact with distant spacecraft and colonies. Another potential solution lies in the stars themselves. Gravitational lensing, a phenomenon predicted by general relativity, could be used to focus and amplify communication signals, turning stars into natural cosmic lenses. The math behind coordinating these messages is complex. We'll need to account for the relative motion of planets, the spacecraft, and the signals themselves. It's a cosmic puzzle that requires precision and ingenuity. Now, let's venture into the heart of darkness itself, black holes. These are not just voids in space. They are nature's most profound puzzles, where gravity defies our understanding and time bends to the will of the cosmos. Imagine a clock ticking near a black hole. As it approaches the event horizon, the boundary beyond which nothing can return, time itself begins to stretch. This is the mind-bending reality of time dilation. Here, time runs slower compared to the rest of the universe. It's like watching a movie in slow motion, but this isn't Hollywood magic. It's the universe's own grand show. This cosmic time warp is not just a theory. It's a phenomenon that affects everything, from the orbits of stars near a black hole to the very fabric of space-time. And it's all thanks to Einstein's general theory of relativity, which tells us that massive objects like black holes can warp the space around them, creating a gravitational well so deep that time itself crawls at a snail's pace. But what would happen if you, our brave explorer, ventured close to a black hole? From your perspective, time would seem normal, but to the rest of the universe, you'd be frozen in time, permanent fixture in the cosmos's grand tapestry. And yet, black holes are not just cosmic traps. They are also creators, spewing out jets of energy and potentially giving birth to new stars. They challenge our notions of creation and destruction, order and chaos. In the dance of the cosmos, black holes play a lead role. They remind us that even in the darkest spaces, there's a possibility for light, for life, and for discovery. They are the ultimate frontier, a challenge for future generations to unravel. So, as we continue our journey through the stars, let's remember that the journey to interstellar space is not just a test of technology, but of human courage and ingenuity. It's a quest that unites us all in a shared dream of exploring the unknown. Let's remember that our choices matter. Each decision shapes not only our destiny, but the destiny of the universe itself. Let's remember that every message we send is a testament to our desire to reach out, to explore, and to understand. And let's not forget the enigmatic black holes. They are not just the end of the road. They might just be the beginning of a new path, a new adventure in our cosmic paradise.